Welcome back to our Intro to SolidWorks video series. In previous videos, we've gone over how to mate parts within an assembly. Up here under mates, we've looked at our basic mate types: coincident, parallel, perpendicular, tangent, concentric, distance, and angle. And we've briefly talked about that there's advanced mates, and then we also mentioned there were mechanical mates. And these are what we're going to focus on in this video, our mechanical mates. Mechanical mates are where you want to tie the motion of one part to another part. So if you look at the different types of mates, you can see that a cam, where you have a surface that follows another surface, a slot, a hinge, that's a fairly intuitive one where you have two parts that are allowed to rotate about an axis. And gears are a little more complicated than a hinge. Here you have two circular features that are going to rotate in coordination with each other, but it may be at different ratios. If you have a gear that's larger than the smaller gear, that gear is going to turn slower, etc. So gear is a little more complicated one. And then rack and pinion, that's a mate between a rotary gear that turns into a linear motion of a rack. And then screw. You all know how screws and bolts work. That's another type of mate that you can make, whereby the rotating of one component, it moves linearly in and out. So somewhat similar to rack and pinion, just with different axes of rotation. So we're going to go over the gear, rack and pinion, and screw mates. And so to do that, first we need to bring in some parts, and I have some parts open. If you remember, in previous lesson we looked over how do you find pre-made models of things, and a couple of the things we downloaded were gears. So I've opened some of those gears. But before I bring in any gears, I need to have something that's going to kind of define the axis of my my first gear that I want to orient everything around. So I just modeled a little pin that we'll use in our assembly. So if we come to our assembly, insert components, I'm going to start by bringing in a pin, and I'm going to, rather than drag it out here, I'm just going to hit the green arrow for OK. And if you recall, that brings it in such that the front, top, and right planes of the pin are coincident with the front and top, right, left plane, front, top, and right planes of the assembly. Okay, so we've got our pin in here. You can see it's fixed, got the little F in front of it. So now let's start bringing in some gears. And I'll start, let's bring in this one. So there's our small gear, and then I'll bring in the larger gear too. Okay, so let's rotate and look at some of these. So you can see we've got one gear that, if I look at the info about it, I think it says how many teeth it is. It doesn't, but I remember that these are basically 2 to 1. So this gear I think has a pitch diameter of 2 inches, and this one has a pitch diameter of 4 inches. So as a reminder, you can always find that information from the gear manufacturer, what the actual pitch diameter is. And you do need to pay attention to that when you're actually designing a model. But today we're just looking at mates, and the mates will work whether you have the exact pitch dimensions correct or not. And I'll show you what that looks like. Okay, so let's start putting things together. I'm going to start by making my pin and my first gear concentric. And so you can see it assumed I wanted eccentric, so it made that guess. That's right, but I actually want it flipped, and this is where I can use that flip mate alignment. So yeah, that's how I actually want it, so that the boss of the gear is facing the pin. And then I'm just going to use a distance rather than a coincidence. I want to leave a little gap there, so you can see it's guessing I want a coincidence. So I'm going to say, no, I want a distance, and I'll put a distance of 1/8 of an inch in there. Okay, so I'm happy with how that gear is now. If we come back and look at it, let me move things back over here. I should be able to rotate it, yep, but I can't move it in or out. All I can do is rotate it about the pin. Okay, so let's now get this larger gear close into meshing with our first one here. So the first thing I'm going to do is I'm going to make this face coincident with this face, and you can see when it's guessing I want it coincident, which I do, but again, that's the opposite alignment from how I want it. So flip the mate alignment, and that's the way I want it. So I'll say, yep. Okay, now let's look at these from the front, and you can see that I can, if we look at it from the top, we'll be able to see that I can move the gear left, right, up, and down, but I can't move it in and out, right? Because I got those faces coincident. Okay, so, but looking at the front, I can still move it up and down, and left and right. And I want to make it so that its axis is on the same plane as the center one. So I kind of want to limit it from going up and down. And your first thought might be, oh, I can just make the, let's find which plane that would be. I can just make the top plane of that coincident with this top plane of this gear. And I mean, that'll work. Now I can move this gear left to right, but when I did that, I can't rotate this gear anymore. And like, see this one, I can still rotate. So I don't actually want to tie that plane because it's going to prohibit me at doing my mechanical mate in the future. So let's get rid of that coincident one. And what I do want is I do want this axis to be coincident. I just don't want the plane. So a way I can get to that is turn on axes temporarily. So if you come up here, you can choose what is showing right now. And so you can see most things are showing, but one that isn't are temporary axis. When I do that, you can see it shows all the axes of anything that had a revolve feature or the center axis of a circular feature. So now if I select that center axis and the top plane, I can make those two coincident. And I'm going to turn back off the temporary axes so they're not confusing things. And now I can rotate it and move it left to right, but that axis is staying on the plane. Again, if we look at it from the front, that'll be more obvious. So you can see I can rotate it and move left to right, but I can't move up and down. Okay, so we're getting close now. Let me show you. You can actually make a mechanical mate without the parts touching. So right now, if we go to mates, and I choose a mechanical mate, and let's get rid of that selection, and say I want to do a gear, I can now, for gear mates, what it wants are two radiuses or diameters of the parts you're mating. So I can pick any circular diameter here. The important thing is it does matter which one you select. So watch, let's say I select this inner diameter here and this diameter here. I can take those and you can see it measured the diameter of this one as 1.55 and this one of 2.78. That's fine, and if I put the mate in and start turning one, you can see that they are turning and they're turning at a ratio. So let's do one turn of this small gear and you can see the big gear has not turned a whole turn yet. It's turning at the rate, but it's not actually the correct ratio between them because I chose diameters other than their pitch diameter. So you can see that by if I bring these in to where the teeth are meshing, and now watch as I start turning, the teeth get off of meshing pretty quick. So like already by just a quarter turn, you can see that the teeth aren't meshing. So if I do want to get it right, which if you were actually designing a machine, you would certainly want to get it right, I need to put in the correct pitch diameters. So I can go back and edit that mate. So that's this one here, edit feature. And like I said, I think I remember that I picked gears that would be nice and easy that had a ratio of 2 to 4. Okay, and so let's try that now. So they're a little misaligned right to start with. So I'm actually going to get rid of that mate entirely so that I can get the teeth lined up well before I start trying to make the mate. And again, I'm just doing this to show you if you were doing this for real, what you would do is dimension the distance between these two axes at 1/2 of this pitch diameter plus 1/2 of the other pitch diameter, which I could do right now, but I just want to show you how this works. So again, I'll go back, create a gear mate. So mechanical, get rid of that. I'm just going to pick 2 so that it knows which parts I want. That's not an appropriate place. There we go. Gear, and say 2 to 4. Okay. Now, as I rotate this gear, the teeth should stay not overlapping. And you can see that they do. If we zoom in here more, you can see that they're meshing correctly as we rotate it around, because I now have the correct ratio between the two parts. Okay, so that's an introduction to gear mates. Let's say if instead of being directly connected, they're teeth meshing, these are actually connected by a belt, a timing belt that had grooves in them. So they're located some distance apart. I still use a gear mate for that. You can see that comes back to what I was saying. They do not actually have to be touching. But if they were connected by a belt, their rotation would be opposite what it is right now, right? They would both be rotating clockwise when one was going clockwise. So I can fix that if I go back to that mate again and edit it. There's a checkbox for reverse direction. So if I just click on reverse now, you can see that they rotate in the same direction. The ratio is still whatever I set it to here. So 1 revolution of the big gear is going to do 2 revolutions of the little gear and vice versa. Okay, I think that's a good introduction to gear type mates. While we're here in this same assembly, let's go ahead and do a rack and pinion gear one. So for this one, I'm going to use the same setup I have here, and this time I'm going to set the distance between these so they're locked. So I'm going to put a distance mate. And rather than concentric, I want a distance of 6, let's see, half of, so 2 plus 1 inch, because their pitch diameter is 4 inches and 2 inches. So the radius of the meshing diameter would be 3 inches and 1 inch. So I'm going to put them 4 inches apart. And if we look at that from the front, that should look, oh, I'm off there. So I must have the wrong, these gears must not be the ones I was thinking I had. So these are nice gears that I downloaded from McMaster Carr, if you remember. So if I open up the gear, they actually have a sketch in them that shows the pitch diameter. So pitch diameter of this one, you can see, is 2 inches. That's what I thought it was. So let's go look at the other one. Open that one. Pitch diameter of this one is 4 inches. So 2 and 1 should be 3 inches. Isn't that? I thought I put 3 inches in. Maybe let's go back and look at the distance. So 3 inches. Maybe I typed 4 in and was confused. I don't remember. Because, yeah, 3 inches looks right. Okay. So now my gear mate's still there, so you can see they're meshing good. And now this gear can't really move anywhere. It's fixed, fully defined. Okay, we can rotate. You'll notice that my assembly still says underdefined because the parts are not fully locked, right? They have a degree of freedom about rotation, so it's not completely defined, but they're locked from translation, or moving in X, Y, and Z, which is what I want here. I want them to be able to rotate but not move in X, Y, and Z. Okay, so let's look at the rack and gear mate. So I'm going to insert the gear rack, and here again, I'll get it roughly in place. I'll make those faces coincident. And let's look at it from the front. Let's bring it down. Okay. So here again, I'm just going to show you the basic mate. I could confine that rack completely, in and out. I just did it left to right with the face there, but we're just going to look at the mechanical mate for now. So now it's going to be mechanical, and it is, get rid of that. So we're going to be a rack and pinion mate. So the first thing I need to click on the rack, I need a linear edge that tells me the direction I'm moving. And then for the pinion gear, I just need the axis or radius here that it's going to move on. So I'm going to click this rotary, and you can see again it assumed 4.07, but I know that it's really 4, so I'm going to change that to 4 inches. And now I'm going to have a system that has 2 gears mated that then control the rack. So you can see the rack is moving as I rotate the gear. And you could do it vice versa. I could slide the rack along and it would rotate the gears, but and you can see it doesn't matter which gear I pick, I can move any of them. So this is another really useful tool or a type of mate that you can use to allow motion in specified directions and at rates that you want. It's important to note that I actually have models that have gear teeth on them. These mates work whether you have teeth or not. I could just have two round cylinders and put them next to each other and make a gear mate, and they would rotate. That's just like as if they were by friction. Same thing with the rack. I don't have to have teeth. All I'm needing is a linear edge, and it will move along it. So keep that in mind. So for the next type of mate we're going to look at, I'm going to switch back over to the assembly we've used before where we were looking at inserting bolts into this flange. And so you can see I've got one of this socket head cap screw in this flange, and right now it's just held fixed where it is because of the type of mates I have on it. So if I want to free up this bolt to be able to move it, I can come in, look at the mates for this one. I want to remove all of them. Okay, so now this bolt is free to move, and now we're going to look at the screw type mechanical mate. So I'll go to mate and get rid of that. So here I'm going to mechanical and screw type, and what it wants here is going to be circular features of the 2 points. So or axes really is what it's looking for. So if I click on that center boss, and you can say this round edge here. So you can see it automatically came up with concentric. You can also see it gave an arrow that's the direction it's assuming. So if I look down here at my specifications for it over here, if I click reverse, you can see the arrow flips to the other direction. And then the other piece of information is the revolutions per inch of travel. So in this case, if I leave it as it is, for one rotation, the screw will move in 1 inch, which is quite a bit more than it would really move. So let's try that and see what that looks like. So, oops, still thinks I want to make another mate. Okay, so see, as I rotate that, it's moving quite a bit, and it's moving in just like you would expect a bolt or screw to move. That's, you know, right hand tightening thread. So let's go back and edit that mate. I remember from when I downloaded this screw that it is a 1/2 inch 13, so that 13 stands for 13 threads per inch. So if I want to make that bolt behave more realistically, instead of saying 1 revolution per inch, I would put in 13. Okay, so let's see what happens now. Now you can see it takes a bunch more revolutions, and that looks more realistic as far as how that bolt would thread into that part. So screw mates, super useful. There are some times where you have non-standard threads, maybe a left-hand thread, so you can reverse it like I talked about. Let's just show what happens if I do that. If I click on reverse, you can see the arrow changes direction, and now to screw into it, I go to the left, the opposite, and you can see it looks odd because the thread, the actual modeled thread here, is a right-hand thread. So as I'm rotating it, it looks backwards from what you would expect. As I'm rotating left, it's screwing into the device. Okay, so I think that's a good introduction to mechanical mates. You can play around with those. You can also, if you want to, try playing with the cam, slot, and hinge ones. Hinge is, you know, pretty self-explanatory. And as always, remember, if you have questions about any of these, your best bet is to come up to help and type in whatever topic you're working on. So help brings up a link to the Solidworks one, and you can just type in mechanical mates and take you to all different types of mechanical mates. And you can, from here, say which types you want to look at. So mate properties, smart mates, all the different help that you might need here. So I hope that's helpful to you. Let me know if you have any questions. Thanks.